just a little review from yesterday. What would be the greatest integer function of, say, 4.21? Okay. But what about if it was 3.9? That's 3. That's right. Okay. And what if it was greatest integer function of, say, 2? That's 2. Excellent. Okay. It's the greatest integer less than or equal to the number. Then the other thing we learned was that this is the absolute value of x. And without a calculator, you need to be able to sketch a graph, say like this one. Okay? What does this tell you to do? Okay, so this means right 2, and what does this mean? Up 3. So you go right 2, up 3, and then that's your V-shaped graph. Okay? Alright. Now, y'all tell me, I want to go left 4, down 4. What should my equation be? Excellent. So that would go left 4, down 4. That's right. Okay? Makes sense? Alright, that was last night's homework. Okay? Tonight's homework, I want you to totally do this on a calculator, but they're going to add one thing to it that makes it a little tough. Yes. Okay, now y'all, the calculator thing I've told you about 5 times. Okay, if you don't have a calculator, you have 3 options. 1, you come in to my class in the morning or during homeroom, and you can use one of mine. Or 2, you'll have to do it on a computer and do it on a graphing calculator on a computer. But I mean, you're in honors class, you've got to have a calculator of some sort. So if you don't have one and can't afford one, I understand. But then you're going to have to come to my room in the morning and use one of mine. It doesn't matter if you have me, Miss West, or Miss Mitchell. I mean, you're going to have the same issues. So, you need to leave my navigator alone, please. You'll leave that alone. All right. Now, so let's go to the handout and let's look at the weird functions then. Like problem number 6. All right, we've got 2 absolute value of x. Now notice that 2 is not added or subtracted or multiplied. I mean, it's multiplied, right? Now if it was added or subtracted, I'm expecting you to know what that thing looks like without a calculator. This one, however, I'm going to let you use one. Okay, so Inspire folks, what you're going to do is you're going to press home. You're going to go over to the right and do a graph. And to do 2 absolute value of x, just type 2. Okay, home, right, to the graph thing, and then enter. Now you're going to do 2. Now where absolute value is you do control times. Control times has this template where all this junk's at. And you'll notice absolute value is on the second line. See that? Second line, first one. If you press enter, you can do your X and get the answer. Okay, 84 folks, Y1, math. Press Y1, 83, 84. Y equals, press the math button and go over, and an absolute value on 84 is ABS. So you do it the same way, just do ABS. Okay, now, so you have that sketch right there, but now how are you going to get that sketch to your paper? Well, you need to plot at least a couple of points on it so you kind of have an idea of where it's at. Now, on the 84s and 83s, what you do is you press the trace key, and when you press trace, you can go left and right, and it'll give you points on it. On the Inspire, what you do is you do menu, and we did this the other day, menu trace, number 5, and then you do graph trace. And what you can do this both on the 83 and 84 and the Inspire, is once you start tracing it, type the number 1 and do enter. And it will tell you where that point's at. It'll do that in the 83s and 84s as well. So say that point's at 1, 2. If I did 2 enter, it would tell me it's at 2, 4. So go to your handout then, and you know it's a V shape, but to get it to look right, you plot a couple of points from the graph, just 2 or 3, and then you'll make a nicer graph of it. So like if I did 0 enter, it's at 0, 0. If I did 1 and then did enter, it'll be at 1, 2. Okay, now if you're not getting these points, if you're doing the Inspire, you do menu, trace, graph trace. And you can do negative numbers, just do -2 and enter. So we got that V-shaped graph there. Okay, now the hard part. Domain and range. Domain's X, right? So what you do is you look at your X-axis. Would you agree that that graph is going left forever on the X-axis? It's going that way forever, right? Is it going right forever? Yep. So how do I do an interval notation if it's going left forever and right forever? Negative infinity, exactly. Negative infinity to positive infinity. Little secret, that's going to be the domain on all of these absolute value functions. The reason why, I can do the absolute value of any real number. I don't care if it's positive, negative, or 0. I can plug it in and get an answer. So domain's always going to be that answer. Range, that's not the case. Now on range, you're going to see this a bunch this year. Range is your Y. You look at how low and how high. That's how you do range. How low on the y-axis does that graph go? 0. That's the first number. How high? Up forever to infinity. Infinity gets a parentheses. 0 gets a bracket. Why is 0 a bracket? It's a closed circle. It's a dot. You include that point. Since it's a dot, you include it, so that's a bracket. Okay, now there are weird problems where it actually could be an open circle there at the origin. Okay, now you're not to the point where you're studying those functions yet, but they exist. And that's the way that would look. All right, now just to be sure you've got these absolute value ones, here's what I want you to do. Do number 7 on your calculator. I'll come around and help you if you need help. Now, did everybody notice on number 7? Y'all should have been able to do that without a calculator, right? That doesn't have multiplying and dividing. That just has adding. Y'all should know. I told you, I wanted to use the calculator, but I could just as easily put number 7 on a non-calculator test. Because what does that +1 to the side mean? You go up 1. Is that what your graph did on your calculator? Sure. It's what we did yesterday. Okay. All right. Yep.
Would you say this is a difference between these templates and the other ones?
Oh, you're talking about like the new ones. The letters are at the bottom. Those, the old templates, the old inspired templates, it's really easy to push a letter when you're pushing a number. On the new ones, it's organized better. So, all right. So what about domain? Negative infinity, positive infinity, all real numbers. Okay, how low? How high? Infinity. Okay. And why is it a bracket?
Because 1 is a closed circle.
That's right. It includes it. It's a closed circle. Okay. Now, 4 and 5. Going up a little bit. Greatest integer function, right? We learned about that yesterday. All right. Now, these, what I would consider as far as, 6 and 7 are kind of the basic average problems. 4 and 5 are a little bit above average. I mean, they're not impossibly hard, but they're a little bit above average, but y'all can handle these. Okay. Now, these two, if you memorize what the basic graph looks like, I taught you yesterday what those transformations would be. Inside of parentheses, or in this case a bracket, what does plus 1 do to it? Left 1. So if you knew what the original graph looks like, you could move the whole graph left 1 and you'd have it. What about minus 3 inside? Right 3. Okay. So we've got to, so we could do this one by hand without a calculator if you knew what the original graph looks like. Okay, so turn your handout over and I'm going to show you. Now when I put this on a test, this is going to be on the calculator part of the test. So you don't have to do this totally by hand. But I'm just telling you, you could if you wanted to. All right, here's what it looks like, and I'm going to explain why. We're going to do an XY chart for greatest integer function of x. And if you just think about it, my graph's going to make a little bit of sense. So what's greatest integer function of 0? 0. What's the greatest integer function of, say, I'm going to put 1 right here. What's the greatest integer function of, like, say, 0.2? 0.5. 0. 0.9. What's going to happen at 1, though? It goes to 1. So here I've got this graph going, but you know for it to be a function, it has to pass the vertical line test. So I can't have a dot at 1, 0 and at 1, 1. I mean, I can't have a point those places. So here's what happens. Say I would have put 0.9999 into it. It'd have been 0, wouldn't it? Because 0 is the biggest integer less than or equal to 0.99999. So if I'm really, really close, it's 0. But what happens when I go to 1? It jumps up to 1, doesn't it? So in math, what we do to show that it jumps, you don't connect the dots. You put an open circle right there. And where it jumps at, which is 1, 0. Okay? At 1, 0, you put an open circle, and then it jumps up to 1. Okay, now you continue it. What if I put 1.1 in there? 1.5. 1.9. But what's going to happen when you get to 2? It's going to jump up to 2. So you connect the dots, and there's an open circle at the last possible place that it could be 1, but then it jumps up to 2. Do you see the pattern? What's going to happen between 2 and 3? It's going to jump there, isn't it? Between 3 and 4, it's going to do like that. That's why this is called a step function. Doesn't that kind of look like stair steps? Looks like stair steps. You need to know. Okay. It would do the same thing going backwards. Okay? All right. So, if you wanted to do the problems on the handout totally without a calculator, you would take that graph and move it left and right. Okay, I doubt most of you are going to want to do that, but you could. Okay, now let's go and do it on the calculator now. Okay. So Inspire folks, we're going to do home and do a new graph. 84 folks, clear out your Y1. Okay. Now, the problem if Inspire folks, if we do control times, greatest integer function's not there. Okay? So, we have to figure out where is it. Well, if you press menu and you look in there, it's not there either. Okay. So here's what it is. It's INT. That is and it's honestly, now you can find it, but it's easier just to type it. Okay, 84 folks, you have to do math, and I think it's in the same column where absolute value's at. You'll have to find it. It's INT. So if you just type INT, parentheses, x, that's how you do greatest integer function of x, and then look what your calculator does. Parentheses above cosine and tangent. Now, graphing calculators, though, aren't smart enough to do open circles yet. So, you've got to realize that what's really happening here is What's really happening here is there is an open circle at the right end of all of these. And I just explained to you why. Because when I get to 1, what's greatest integer function of 1? It's 1. That's why it jumps up.
Oh, stairway for me.
At the right end of it. The left end, it's a closed circle. Okay, I still got a couple minutes. She's on early again.
Billy Ray Pierre, Jessica Maslin, Ida Parrish, Leslie Boyd, and Pierre Davis.
Okay, hold on just a second. All right, so let's at least get the greatest integer function one done on one of them on the front, so I can tell you domain and range. And we kind of are officially a day behind schedule now because I'm only halfway done with this. So we'll have to spend another day on this Monday, but that's okay. All right, so look at number 4 real quick. Greatest integer function of x plus 1. So what you're going to do, I'm going to do Control G so I can change it. And it's x plus 1. Josh says it's going to be moved left 1. And he's right. So you see what it does? You would copy this the best you can at each place. You just do enough so I can tell what it is. But now here's the hard part. Domain. Because I can do the greatest integer function of everything. The range is the tricky one. Notice, I have a y value of 0, but do I have y values in between? In between? So what do you think the range is? It's all integers. Okay. All right, get started on this. You're not going to be able to finish it. I'm going to have to finish this Monday. So we now are officially a day off schedule. Have a good weekend.
Did you get the
What now? No, I haven't had a chance to scan it.